My name is Francesco Ledda. I'm K5URG. I happen to be the president of Collins Collector Association. I don't know why they select me, but they chose to do that. So I'm an engineer. I start working, I was an officer in the Italian Air Force. And after that, being an engineer, I ended up working on missiles for a few years. Then the Cold War was over. You know, remember? The money went down for defense. I moved to telecom. I worked for Collins for a while. Rockwell International Collins Division doing fiber optic stuff, you know. And then I always loved radio since I was a little kid. And I always wanted to have Collins, but, you know, as you well know, Collins was pretty pricey. You couldn't afford it. And then I kept my interest and I was intrigued by Collins. Collins intrigued me for their innovation and quality. And being a part of the design team that built big equipment, I was not focused on the amateur radio stuff. Just a few days ago, I was looking at the annual report. By the way, I apologize for my California accent. I'm from Italy. So if you don't understand me, just wave at me, I'll stop. I was looking at annual report of Collins 1968-69. Somebody gave me this book. I went through things that they would talk about all the different revenue stuff. I realized that amateur radio for Collins was just a little blip in their business. But if you study their technology, you could see like their big iron, the heavy stuff we're doing for the government and for commercial, had a great influence into the M radio. M radio was not their focus, but their M radio business benefited from their know-how. Most amateur people, amateur radios, they only focus on few things. They call it S-Line or TCS or KWM 380. And most of them are very interested. How did we get here? How did this guy do it? So we're going to talk about Collins from 1940 to 1980. Why do I stop at 1980? Because by 85, you know, Collins was acquired by Rockwell International in 1972. By 1980, the influence of Arthur Collins was pretty much gone. Collins became a telecom company focused on business revenue. There was no innovation coming from the top. The guys running Collins after 1972, they were great guys. They made a lot of money, but they were business guys. They didn't have the vision that Arthur Collins had. Okay, so that's what we're gonna cover. And stop me if you have any question. Okay, this is what I talk about. When you take Collins, that's what we see. But as I say, it was more revenue. As I said, in 1940, in the 40s, there was a war going on. The U.S. did not get the war until December 7th, 1941. But the American industry was focusing for an upcoming war. They knew it was coming. They just didn't know when. They were helping the British. They were helping our allies. And the American electronic industry will focus on that. Who were the big guys? At that time, RCA, Western Electric were dominating everything. And there were many projects, there were many projects that the Department of Defense, or at the time the Army, Department of the Army and the Navy wanted to do, but they couldn't get any help. So when we look at 1940s, we look at communication with 4 major problems. Radio tunings was not digital like we have today. Sometimes you have to have a crystal calibrator to figure out, then, okay, I'm a little bit off, you move it, so you need to have a crystal calibrator. The throughput, basically, the date in which it transferred information was very slow. You had to go CW. It worked fine. It went far away, but the throughput was slow. Tuning an amplifier was not easy. The Army and the Navy had to train people to do that, because otherwise you blow up the funnels. It doesn't work. And therefore, buying a radio for the Army, the Navy was not enough. They also had to train operators. I think Collins realized these 4 things were a problem. So Arthur Collins, if you look at the technical background of what Arthur Collins did, initially did a lot of work in the area of mechanical device to allow position sensing and position tracking. And he came out with this mechanical device in which you could store a position of a device and through some gears and other things, be able to repeat that position. If you guys know, the RT-13 is a perfect example of that. And then, Collins had some patents in this area. And then at the same time, he thought, if I could couple mechanical device with servo amplifier, I can create automation. That's how he started. You remember, Collins sold audio-tuned devices that were used by other people besides Collins themselves. Then Mr. Collins said, I want to find a way to tune radios in which there is no guessing. And 1940 tunings, BC348, BC221. You guys know this stuff. This stuff was everywhere. The 348, it was on the B29, didn't even have a crystal calibrator. The airplane flew from being on the ground at 80, 90 degrees outside to minus 20 at 10,000 feet, 20,000 feet. The radio, you guys know temperature is not friends of frequency stability. So tuning the radio was not really easy. Collins came out with a way to remove all the guessing. And one of his guys in 1948, Melvin Dawes, designed the basic thing for frequency synthesizer. Not a frequency generation system. I don't even call it synthesizer. Was multiple oscillator tied to a crystal oscillator with true filter. You were able to select the frequency you want. For a pilot flying an airplane, this focus is flying the airplane, not to tune a radio. For them, be able to just tune the radio with knobs without giving to gas was very important. By the way, if you could do that, you could get rid of the radio operator. That's 200 pounds of weight, and then it also cost you less. Then mechanical filters. Mechanical filters were not invented by Collins. This guy, Robert Adler of Zenith Electronic, came out with these mechanical filters. But they were massive things. Mr. Collins realized the mechanical filters were very important because he could remove LC tune filter that were very hard to tune, time-consuming, and very expensive. And also, every time you did the maintenance of the radio, you retune them. Mechanical filters, they are pre-tuned. So Art Collins get this design of mechanical filter ideas and was able to industrialize them to the point that could be manufactured in high volume at lower cost. Single sideband was invented in 1915 by somebody at American Telephone Telegraph. It was not called AT&T at the time. And Western Electric used this single sideband to put multiple telephone calls on cable. Remember, they had cables going across the ocean. So, and since they did everything with LC filter. They were talking about huge, we call multiplexer, that get voice channel, split a band with NF, and put them all together. And a single sideband has two things. Increase the reach, because you can go farther away as you concentrate the bandwidth to F with an AM, you have double the power. And then you also have some improvement from a noise point of view. So what good thing, but was not at the time usable in radios. Collins did these four things. It put them together, it put the synthesizer idea, the electromechanical, the mechanical filters. In 1957, came out with a radio called the ARC-58. The ARC-58 was designed at the highest level, not the final radio, with Collins funding. So they owned the design. And this radio was an airborne radio. Where did it go? It ended up into the B-52s, early B-52s, AKC-135. Why? Because the competitor radio was an RCA called ARC-21, ARC-65. The ARC-21 165 is 30-gallon drum. It's huge. Was about 350 pounds. And with reliability time between failure about 3 hours, 4 hours. Collins did called the Air Force and said, "Hey, we got this radio. You guys want to come see it?" The Air Force came down there, but this was an unsolicited proposal. Typical Collins and things. Calls the general, "I have this, gotta come and see it." They came and look at, and the Air Force say, "Ooh, we want it." So they bought him. They showed it to the Navy. The Navy say, "Wow, we like it, but we don't want it. We want something else. We want to put a radio in the submarine, in the Navy, in the ships." They took this ARC-58 few boxes, and they make it the radio on the right, the URC-32. The only thing the Navy wanted, did not want auto-tuning. So they removed the auto-tuning portion, and they put it in there. And that's how Collins got hold the HF market. These are the first steps. You see, now you have a radio with, you can tune, you don't need the radio operator. The PA tune itself, the antenna tune itself, get rid of one person, simplify my life, and it actually has high reliability. This radio, I have one of these. It's 1958 and works like a champ. There's 4CX250, and they're pumping 900 watts all day long. 1958. And when you remove the case, and you tune it, and you see all the motors moving, all the automation, the antenna gets cut. You see the SWR going from whatever it is to almost zero. You say, wow. I don't know. Collins, I always said this before, Mr. Collins in his, if there is a reincarnation, I don't know if there is a reincarnation, probably there is not. But if there were reincarnation, Arthur Collins was the son or a Chinese restaurant owner. Why? Because he recooked all the food over and over. He warmed it up. He took this ARC-58, he put it in a box, called the army, say, "Hey, you gotta have this for the army." And they bought this, what's called Track 75. Now we go back in time, 1940, 41. The Navy's preparing itself for war. And you guys know the submarines, German submarine was the biggest threat to helping the British. The submarines were sinking everything. The German submarine reported for duty every hour. They call, they say, "We are located in a box," whatever the number was. So the guy Donitz in Germany knew exactly what to do. You got to move here. They had information. And the only way the Navy could find out the submarine was through radio triangulation, receiving this signal every hour. Because at that time, in 1941, the U.S. did not have an airplane that could go far enough to cover all the Atlantic. The Navy got hold of a very good directional finder that the German made. They went to RCA and say, hey, can you guys take this thing and build 20, whatever, a certain limited number? RCA told, no, we're busy building 1 zillion radios for the Army. They went to Western Electric. Western Electric say, oh, we are busy doing this. So a captain of the Navy went, the new Arthur Collins, went there and say, hey, we got this box. Can you guys engineer and do it for me? And Collins said, yeah, of course. Collins did not love re-engineering somebody else's stuff, but I think he understood, this is me putting words now, the value of that. And this thing built the relation with the Navy. And Collins benefited from the relation with the Navy for many, many years. Now we go back to 1945, 44, 45. The US Navy was fighting the war in the Pacific. That's the US Navy really fought the war. They won the war in the Pacific. The Japanese were losing the war, and the Navy operated what's called in task force. A task force was a carrier with destroyers, heavy cruise ships, whatever they called them, submarines, and they worked together in groups because the purpose was to defend the carrier. The carrier had the value because it was the offensive force. A carrier group in 1945, 44 was about 30 miles radius. That's how I moved. The Japanese know were losing the war, but they were very committed. They were educated. The dying for emperors for Japan was an horrible thing. Bless them for that. I don't know how they did it. And we all know about the kamikaze. What people don't understand, don't have clear, is the kamikaze were not one and twos. They came in hundreds. And the purpose was to get 1 or 2, 3 of the hundreds airplanes to be able to pass through and crash in a carrier on a big ship. And when you have an overwhelming force, hundreds of airplanes attacking you, it's hard to figure out who is doing what. Remember, the task force idea is to protect itself. But there are 50 airplanes. Who's shooting who, nobody knows. Because the airplanes are going 300, 400 miles an hour. They're 3 miles away. These things are seconds. Who's shooting that? So it was totally disorganized chaos. Because in a Navy ship, there is the Combat Information Center. It's the place where all the data from people looking, from early raiders, comes in information, and somebody decides, you shoot this, you shoot that other one. So the Navy knew that it was difficult. Okay, now before 1960, the search radar found the enemy. The sonar locates a submarine. They need to talk to each other. I see this target. No, I don't see it. Who is close to that? Somebody was plotting the thing on a plexiglass screen. And somebody was making decisions. Somebody else had to communicate it. It didn't work. It did not work. Then came the atomic bomb. What does the atomic bomb do? They had the huge destruction capability. The atomic bomb took the task force of a Navy and spread out to 100 miles. Why? You don't want a single bomb to destroy all of them, so they had to spread away. So now it became an even bigger problem. The Navy was looking at what the U.S. Air Force was doing. The U.S. Air Force was focused on catching Russian planes came over the pole. But they had huge radars on the ground with huge antennas, with a lot of gain, so they could discover an incoming target 2 hours away. Then the Navy had, the Air Force had space. They had analog vacuum tube computers as big as Walmart, getting all this data and decide who's going to shoot what. The Navy cannot put a Walmart in the bellow ship. They don't have enough power to run it. They don't have enough cooling power. So some guys in San Diego in the Navy, they say, we got to find out a way to do this, because if there is another war and they use a similar, we get a massive attack on us, we'll be dead meat. And a Navy captain, no, a bird, not more than a bird, Navy captain in San Diego got Hughes Aircraft Company that was owned by Mr. Hughes, Collins Radio, and what's the name of the company? What's a computer company? What was that? Sorry. Sperry Rand. They put them together and say, hey, we got to find a better way. We got to get all the radio information coming, target information coming from all the shipping task force, talk to each other so we know exactly what's going on automatically, and basically transmit information. And even a computer analyze the threat and telling us which target we should attack. So you do this, you do the other one, so we can fight a war. So they got Collins. Collins got their radio. They built some modems, early modems, modular demodulator. Hughes got the display and digitized the radar data, because before it was analog, And Sperry Rand built one of the first solid-state computers. They put it all together super secretly in San Diego. And they started experimenting. As you well know, there is no secret anywhere. This was all black program. But rumors within the Navy start coming up that the Navy was putting a computer in the Navy to replace the captain. That's how the thing got interpreted. All the captain, admirals that got all pissed off, sorry for my language, say, no computer is going to make my decisions. Blah, blah, we don't want it. So the Navy did a demo. They got these admirals, like captains, to come to San Diego. And they saw this thing coming out. They simulated. The Android's airplane coming in, and these things start working. Automatically, the display showed the targets, which one were enemy, which one was enemy, which one was the closest one. It started assigning targets. The story was there, it was the closest one. They had the best weapon for the thing. It got the target automatically. The target went to fire control, and the thing worked on its own. These captains, the first were, we don't want it. They start saying, I think I want it. Where can I have it? So that's what happened. So the NTDS, Navy Tactical Data System, a few things: display and sensor to display stuff, a computer, crypto boxes to crypto information, a modem, and the radios and antenna couplers. Collins was focused on the modems, radios, and antenna couplers. I'm going to show you a few things, but this is 1959. This is the first solid-state computer. It's not very big. It was slow, but it was fast enough. The storage, of course, is on tape. These were the console. They replaced hundreds of men. The men did not disappear. They just became technicians repairing this stuff. All unmanned. And Collins did the radios and the modems. The same technology you see in these radios found its way in different format to the S-line. Why was the S-line so good as a receiver transmitter? Because the same people design this stuff, they move to other things. They take their pieces and they integrate it in more commercial application. But this is the reason why Collins is so good. They were doing other things that were more important financially for them. This is SRC-16. It was in service probably until the early 80s. There are multiple receiver transmitter, all automatic tuning. It was on all US, NATO, and Seattle ships. This is not an expensive stuff. This is big, completely automatic. Can you think when I was a kid in late 60s, early 70s, they were still selling vacuum tube computers, vacuum tube radio, televisions. These guys were already transistor moving to integrated circuits. In 1967, 95% all production of chips, ICs, the great circuits, were used by the Department of Defense. That's how advanced Collins was. These were the first modems. You know, basically they get digital data, they transform it in PSK, PSK, and they have data moving around. Collins supplied the network radio system, but before talking about that, I want you to understand that we all know what the internet is. Connects computers together. These guys were doing a networked solution on a 200 miles radius between Navy ships. So is it different what we're doing to the internet today? No. They weren't thinking about the internet, but it was a networked system built mostly on vacuum tubes and early transistors. This was a big deal. This was really a lot of money. Collins took this early SCR-16 I'll show you. It was part of a radio system called URG-1, Universal Radio Group. Collins had in mind one thing: how can I make these things easily repairable? Because he knew that some of the radio he had was very complicated. Sparing parts was not easy, especially on a boat. You have limited space. So this radio was already modular. I'm gonna show you things. This is the URG-1 basically was the evolution of the ARC-58. They built one of the first radio called a 618T. They were building about 6,000 a year for about 25 years. These went on all airplanes, from Air Force airplane to 747s. This is one of the most well-known and famous radio. This was part of URG-1, you know, that you see it, they start doing modular things. And modular was important because it allowed people to swap things and plug them in, it works. You don't have to troubleshooting or doing a repair. You just, okay, this modular, you put a new one. Of course, Collins did a lot of black programs. Probably 50% of the programs were black. Black means that beyond the control of Congress, and nobody knows what it is. This was the palette that they could put in an airplane to take generals, and they had the full crypto communication suite. Am I going too fast? This was URG-1 or Air Force One in 1975-78. This was Air Force One. You can see lots of radios, but you know, when the president travels, then he needs to be able to give the important orders. I already talked about 618T. The 618T, the Chinese restaurant thing, they put it on an airplane, they put it on army trucks, they put it everywhere. Collins was very good reusing the technology. They were so well known. Arthur Collins had personal relation with General LeMay, other generals. He was able to call people, say, and he had enough, was so respected that when they told them, you gotta have this, they say, we gotta have it. There was not only his powerful technical capabilities, also his know-how was respected as a guy with a vision. After URG-2, they went to, URG-1, they went to RG-2. At that time, Arthur Collins was already in his head computer communication. You guys probably heard about the SYS system, was a computer that people think you want to compete with IBM. It was not competing with IBM. Reason why IBM was a mainframe in which the information was brought in manually, did the computation, get an output. The Collins computer was a communication device. Initially, the first application of the Collins computer was airline industry. Why? You guys remember the paper tickets? When they got to buy an airline ticket, somebody had to write it, and then they made a mistake, they had to mark it, they had to call somebody, I want this guy in this seat. It took 20 minutes, 30 minutes with reservation. And then if you were in a little airport like, I don't know, Timbuktu, where they have a commuter plane, and your airplane gets delayed, there was no automatic rebooking. There was somebody calling, well, get back to me in an hour. It was a mess. And Arthur Collins said, I want to get rid of all this crap. I'm going to use my computer, and my computer is going to manage the messages. I'm going to give terminals to the airlines. And that's what he was doing. He was basically doing computer communication, making later computer do like it did for the Navy tactical data system to the network together and move information automatically. And when Rockwell International acquired Collins, I don't think they had this tool they had with the Collins computer. In fact, they shut it down. Because why? The visionary man was out of the door. They bought the company, but they got rid of the guy with the vision and the ideas. You know, we all have worked for people. There are some people, some of our bosses were visionaries, saw things we didn't see, saw where the business was going, where the company was going, where the market was going. They were able to foresee and apply resources to make a future. Rockwell International bought the company, bought the hardware, bought the business, but they did not understand the vision of Arthur Collins. And that's what's really, really sad. Because I worked at Collins after Arthur was gone. Of course, I was there like 15 years later. The only thing left at Collins at the time, my experience, was the quality of the products, the commitment to do certain things. But there was no visionary tell us where we're going. We knew where we were going the next day, but we did not know where we're going to be 3 years from now. I was an executive for a few corporations. I tell you, vision is very important. Vision is what is going to build your future. If you don't have vision, you working in a forest with a little candle. You can't see very far. Okay, I'll go to the next level. So after our G2-1, we went to our G2. Our G2 was the time of integrated circuits. As I told you before, there was computer. So Arthur Collins got integrated circuits that now allow him to miniaturize things, do things he couldn't do before. But also, he got computers. Let me see what time it is. How am I doing with time? Oh, I still a little bit time. And if you see this, this is part of a brochure. There is an airplane, AWACS. There is a Navy carrier. There is a cabinet. Your G2, again, was modular. And see this picture? There is a computer now. Computer controlling DCU, DCFE, sensor. Now it's putting all together. Computer with radio, modular. I can do, now that I can do more electronics because I have IC, I can do better performance monitor. In telecom, performance monitor is everything. What is performance monitor? Finding out how the equipment is performing by information the equipment is providing to you. My laser bias is getting out of whack. I'm gonna fail in 300 hours. That's performance monitoring. Because you can drive action before it fails and fix it. When the laser diode fails, you don't have enough laser power, and you lose traffic, that's too late. Collins had this in mind. Be able to remove the need to super tax. Get just regular people to look at lights, say, this module has failed, go change it. It's very important because, training people is expensive. And then equipment gets more complicated, it's becoming more important. URG2 ended up, with the first radio URG2 went up an SR-71. This was a black program in which most people working on this radio went to SR-71, did not know what they were working on. They know they had to do it. In 66, 67, the Air Force, the CIA actually, got an HF radio for Oxheart, the A12 SR-71. So why this airplane need an HF radio? Because they go far away enemy lines. When you go far away from enemy lines, as you well know, you need an HF radio because VHF, UHF is not going to take anywhere. SATCOM did not exist. And the radio, if you look at this radio from this 718T, from a block diagram, it looks like a regular radio. It has a preamplifier, has a mixer, has a synthesizer, down converter, etc. And somebody called Ed Andrade figured out that he could simplify the design of the synthesizer. Why? When you have a 2 to 32 megahertz radio, you cannot build a simple one oscillator, local oscillator, because you're going through many octaves of frequency. You cannot build a VCO that covers from 2 to 32. But you can build a VCO that goes from 100 to 132 megahertz. Now, so instead of down converting to 500 kilohertz, he converted to 103 megahertz and was able to shrink the VCO from a big box to a single card and cut the cost. When they did this, they did the calculation, they saw there was huge saving. They took the 718 T6 that was on SR-71, they removed the T, put the U, and did the up conversion. This changed the paradigm of cost and hardware simplification. Was a great thing. From that on, all radio had the up conversion, all professional radios. If you look at the KWM 380 as an amp conversion, is directly derived from this. Computers, this is 1967. This is a 671 U4 radio that's a CRT and a keypad. 1967, vacuum tube TVs, 5 channels with a big switch. You remember? This is what it was doing in 1967. This is what it looks. This little box, this wide, it's a computer with 3, I call under quote, ICs. In 1967, he had the base to build the first microprocessor. You have all the pieces. This is a computer. 1967. When Rockwell International bought Collins, they did not understand this was basically the first building block for a microprocessor. And they shelved it. A few years later, Intel was dominating the market. This is what happens when you buy a company and understand what you're buying. You should know what you're buying before you buy it. You should get the smartest people you have, go figure out all the pieces we have before we shut them down. This is your G2 family. These are things that went everywhere, from AWACS to other things. Also, there was a proposed KWM 400 radio based upon this. The only probably the owner of General Motors could buy because it was so expensive, but that's what their plane was. That's how they look. This is a KWM 400 1000 with a remote control head and the amplifier, the receiver. You guys ever heard of Takamo? Okay, this is what TACOM was part of. I don't know where I got this chart. I hope they don't put me in jail for this. This is 1968, 69. It shows the communication path between our missile silos, air bases, and submarines. You notice that there is a TACOM airplane. TACOM airplane talks through UHF to a satellite, UHF, VHF, VLF to the Airborne Command, A4. The Airborne Command talks to the Pentagon, the White House. This is how the US kept itself safe. Collins was involved in all these things. Their equipment was everywhere, from submarine to TACOM to the Airborne Command to missile silos. They didn't have everything, but they had what's called the TACOM program. TACOM means take charge and move out. Basically, you get this airplane out, flying, communicate it. They have this long wire antenna, miles and miles, that get dropped from the tail of the airplane. It talks at very low rate to the submarines. This was TACOM 3 in 1967. A friend of mine that passed away, Lonnie Duncan, was the Collins guy responsible for this. He was kind enough to give me these pictures. This was the TACOM console inside the airplane. If you see teletypes, radio controls, etc. This was on the C-130, was the 100 kilowatt amplifier VLF transmitter. The airplane was modified to put special generators, because in order to generate 100 kilowatt of power, you need to probably have 150 kilowatt in power to drive it. These are a picture that probably very few people saw, was the long wire antenna reel that released the antenna on the tail of the airplane, miles, with large barometer. They did the antenna tuning, all automatic. This is a follow-up of C-130 that we still have today. Oh, I want to show something else. Okay, this, I don't have this picture, but this TACOM radio was controlled by this little computer here. So Arthur Collins in 1966, 67, had an edict. You know, when you boss own a company, you can have any edict you want. The cafeteria is not going to sell bacon. Okay, you're the boss, you're crazy, but we want bacon, but we're not going to have it. So the edict was no knobs. The radios will have no knobs. I don't want anything that. So the Navy at the time, they wanted knobs. So Arthur said no knobs. So the Navy said we want knobs. So they did this. They put knobs, they interface to a computer, the computer did the things. Arthur Collins was AP, and the Navy had knobs. So Collins had a beautiful receiver called the 51S1. You guys know the 51S1. It was very costly in 1967. It was all pretty much handmade. And they needed a new radio to replace it. A group of guys in Building 412 in Richardson took a URG2 box, receiver, exciter, and secretly put a display and knobs. And it was a skunk work within the company. There was an edict, no knobs. These guys were putting knobs because the customer wanted knobs. You know, it's kind of crazy. And Arthur Collins, I was told by a person that was there at the time, it's witnessed this. He used to walk around the company. When I was executive, I did that myself. I always walk around. Why? I want to get the story from the people. I don't want to get people, my director to tell me what they want to tell me, what they want to hear. I want to know what's going on. And the people, they know, the people in the factory floor, people doing the design. I used to walk around there. Hey, how's it going, man? How's your family? What are you guys working on? Oh, we have this problem. Okay, it's important, I think, to really know what the troops are doing. I learned that in the military. And Arthur Collins did. He was walking around 412, building 412 in Richardson, and he saw the first 651 S1 with a tuning knob. And he say, "What's this?" And these people say, we don't have a job today or tomorrow. And Arthur Collins sit down. You guys know the 651 S1 has an optical encoder. He start playing with this. And he say, "Isn't this neat?" He asks a few questions. Say, "Well, this is not a regular knob, it's a digital interface to the computer." Basically, they did the same thing we're doing on Takamo. And he liked it. They didn't get fired. And that's how the 651 S1 was born. And we'll talk about 651 S1 later because I have a question for you later. So now I lost my thoughts. Space program. Collins was involved in the space programs. Didn't do everything itself because they use our supplies. Motorola was involved, our companies were involved doing pieces. But they were on the Mercury, they were on the Gemini, they had VHF, UHF, and HF radio as well. This is from the Gemini, this is a Gemini control head. If you note there is a switch, HF, intercom, HF, HFDF. Then you have VHF, other things. That was from the Gemini. Then they did same things on Apollo and on the lunar excursion vehicle. So Mr. Collins did not like working with NASA too much. Not because of anything work with NASA, but NASA was focused on bringing people back. So they didn't want to experiment too much. They want to have proven technology. And therefore, Mr. Collins could not innovate too much. But it was a big business for a couple of reasons. There was a lot of money. It was government business. And also, when you say I put the radio on the Gemini Apollo, and now you're talking. Who's going to be able to say that? I took these pictures at the Collins in Cedar Rapids. These are the typical box that went on the Apollo program. If you guys go to Cedar Rapids, I think there is a corporate display. I don't call it a museum, call it that you can see some of this thing. I don't know who you need to talk to, but you're able to see some of the stuff that went on Apollo. Also, Collins did the NASA ground station. These were big money. This is a unified band. Remember one thing, the Apollo communicated digitally to ground. In that sense, they already had, the performance monitor I told you that you know what the equipment is doing. They were sending a lot of data back to computer. They were displaying all the system of the ship, the spaceship was doing. They were able to figure out the heart rate of the astronauts, and they need ground coverage all over the planet. So they have ground station everywhere, the US, in Australia, in Spain. And Collins was involved in these things. So now you can think people, they only focus on S-line. I think they're getting hopefully an understanding of the breadth of their program. The S-line is so limited, it's an M radio. But look all the things we're doing. When it's like when you work there, when I work at Rockwell International, we did the telecommunication stuff, fiber optic stuff. But at the same time, the company do the space shuttle, the B-1 bomber. We were not involved in those programs. But, it kind of percolates with the company who you are, how proud you are to work company that can do so much. For us, employee was a great pride. The day our division was sold to the French was probably one of the saddest days of my life. Because I'm an American by choice, because I was not born in this country. I wanted to work in an American company. I tell you, this was the saddest day of my life, the day in the campus of Richardson in Texas, when they lowered the Rockwell International flag and they pull up the French flag. I didn't like it. Nothing against the French. This is not about that. This is about being proud of working for a good company. I know this is a thing that doesn't happen these days too much anymore. But that's what's very, very, very important to us employees. I'm approaching the end of my presentation. I'm going to talk a few other things. I'm going to talk about the HF80 and KWM380. Then, as I told you, I'm going to stop. Reason why I stopped, because after that, Collins was the name, but I don't think Arthur Collins was there anymore. Late 70s, the Vietnam War was over. We spent a huge amount of money in the Vietnam War. I have a Collins book, a manual, that talks about the telecommunication system that Collins built for Vietnam as a country. Lots of money. Unbelievable. Troposcatter, satellite, HF, money was not an issue. But when the war was over, they start cutting, they got the knife. A few guys already had left Collins. They create a company, Rochester, called RF Communication. RF Communication, the guys that went from Collins RF Communication, they understood one thing. The URG2 system was very expensive. Was modular, computer, performance monitoring. You put it all together, it's a big bill. They say, okay, we're gonna create simple radios. They still got a module, but they don't have any performance monitor. They're gonna be cheap. Cheaper. No, they're not cheap, cheaper, less expensive. The good quality of equipment, and nothing wrong with that. They went to the Navy and told the Navy, you guys are buying this Collins RC16, the big system I show you, multiple racks. Why don't you try use our system? It costs 1/3 of that. And the Navy did the program, they put the SRC16, they put the Ares URT-23, the one on the right lower. They did the test, the thing worked. It was simpler, cost less. Basically, Collins was losing the edge because the other were catching up. That's the bottom line. The world had not understood the value of radio computer communication yet, because Collins was much ahead of everybody else seeing it. So they start losing business. So they took the URG2 from an architecture point of view. By architecture, I mean the high-level design, how it works, all the conversion scheme, the amplifiers, and they made the HF80. The HF80, when you buy an HF80 equipment, you buy basically URG2 redone in different form and fit, not in function. It does the same thing. The HF80, they're available. It's a good radio, piece of radio. It's wonderful. It does the stuff, and it is Collins. As a receiver, it's probably still hard to beat. The HF80 was bought for the commercial market and also for the military market. The military market, the Air Force, the Navy some, and the Army used it heavily. A beautiful system. It's pretty inexpensive. The only problem they have that's that those tantalum capacitors built in the 80, they fail. But besides that, they're beautiful radios. Then they come out with KWM380. Was the end of Collins amateur radio business. Was the last radio. This is a beautiful receiver, and he used the same architecture that the HF80, a little bit different frequency up conversion scheme. Is built with in mind commercial cost. They've tried to build for the military. They didn't. I don't think they were very successful. But this is a wonderful radio you can get on the market for probably $1,500 to $2,000. It's a beautiful radio. It's high performing. Now, this is the end of my presentation. I have a question for you, and I'm gonna tell you my opinion later. Which one is the best Collins receiver from the 50s? Which one the best receiver from the 70s? I open to suggestions from you people. What you think? From the 50s? From the 70s? Anybody else? The best receiver is a 651 S1. It's the quietest receiver. They're fairly inexpensive, and you're not going to be able to beat it with anything else. Their first conversion mixer is unbelievable, taking overload. And these are the best radio. A 6051 S1 you buy today, you probably beat any of the radios you have, including flex radio. These some of the, so I'm approaching the end. Actually, this is the end. I'm gonna tell you about our organization. So did you guys, everybody pick up a raffle ticket? Anybody without a raffle ticket? Do you have it? No? Anybody has doesn't have a raffle ticket, we'll give it to you. Okay, raise your hands, they're gonna give you the raffle ticket. So we're a bunch of volunteers. So volunteers, they work where they want. That means most of the time they don't do anything. And you cannot fire them because they volunteer. We have a quarterly magazine, which we cover from history of Collins to Collins equipment. Our goal to preserve Collins history. Why is it important to me preserve Collins history? Because unless we learn from history, we're not gonna do well in life. We don't want to repeat, I don't want to repeat my parents' errors, even though I've done them. We don't want to repeat other people's errors. I think there's a lot of corporation, and I told you, I spent the last few years as an executive, don't have sense of their history. I think it's a mistake because you want to learn from a mistake, you don't want to repeat them again. So that's what we focus on. And you guys welcome to join. The membership is $35. You get the magazine. We're looking for volunteers to update our website. Our website is still a work in progress. We're gonna be adding about 50 gigabytes on unpublished Collins documents that people are able to see. We try to preserve history, and then if you don't wanna be a member, just join our reflector, be part of it. There are a lot of people willing to help and talk about things about Collins. This finished my presentation. I hope you guys find it enjoyable and you learned something about it. As I told you, Collins was a great place. Like many American companies, I work for NCR, they were good companies. They all lost their way a little bit, and we see what's happening these days. They try to fix some of that. At the end of the day, you gotta make the right decision, and you gotta have vision. No vision, you don't know where you're going. Sometimes what we as kids don't have vision when we're kids. We wanna do this, we wanna do that, but we don't know where we're going. Corporations are the same.